doing a presentation on two-wire irrigation systems. And I know there's a lot to cover on that, but he's going to try to abbreviate a lot of the stuff and hit on a lot of hot topics that you all have maybe questions about. So before I begin, I just want to tell you a little about our association. If you're not familiar with it, it's the Northern Chapter Sports Turf Managers Association. We represent sports turf managers, and not just turf managers, and people who work in that field or in that industry, whether they be vendors, parks, schools, private landscapers, and so forth. So we're a nonprofit industry, and we're trying to spread the good word of our industry and help one another, our brothers and sisters in the organization. So with that being said, I'm going to share my screen over to Craig. And Craig, I'll let you take the reins from here. Okay, sir? Let's see.
Thank you. Let's see if I can do this correctly.
There you go, buddy.
Now, are you able to see my screen with the two-wire presentation?
We are.
Yeah. All right, I got a thumbs up. I love it. Welcome, everybody. I appreciate you coming to listen. I've been with the Toro Company for 27 years on Thursday, my birthday with the company. Of all the days, April 1st, I thought is rather fitting for me. Before that, I worked for many different manufacturers. I've been a contractor. I've done installation. I've done a lot of consulting, repair work over the years. So I've embraced the technology and the technical aspects of our industry a lot, and I enjoy every bit of it. And I guess with the background, my father was an electrical engineer, and growing up, all my gifts for Christmas, birthdays, and whatnot were the electronic things to build and repair, in the hopes that maybe one of his two sons would become engineers when they get older. And that didn't really happen. My brother went into pharmacology, and I told Dad, I want to do plants. And he goes, that's it. You're not my son. Get out of here. Well, my first job was out there, and they said, Craig, if you want to have a desk, it's underneath that pile of stuff over there. You can figure out what's wrong with them. You can have the desk. So I started digging through. I said, hey, Dad, can I get my voltmeter and oscilloscope and soldering iron back? He goes, why? You're dealing with plants. I go, yeah, but they got sprinkler timers that need to be repaired to work with them. And he goes, my son has come home. So I've got a lot of technical background over the years. And what I want to share with you folks today is just an overview of what two-wire systems are, what nuances you need to be aware of when working with two-wire. There's some design aspects in here, there's some installation aspects, and there's a brief troubleshooting portion of it and some wire connection pieces to it. So I would love for anybody that has a question. If you got a question, try to raise your hand, and hopefully I can get interrupted to get the question taken care of. But there's a lot to cover. This is a class that normally takes 4 hours to teach. There's a lot more hands-on involved. So hopefully this is an introduction to give you guys the desire to learn more, and maybe we can get together again and dwell on or dig deeper into some of the presentation. So that's my introduction. That's a little bit about me, a little bit about the class. So let's get started, shall we? Now, I want to talk about what a two-wire system is, some of the basics or the critical pieces that need to go in when you're doing a design. And of course, we're going to follow up with troubleshooting. So that's the goal. I want you to be able to understand what a two-wire system is, what makes it different from a conventional system to a two-wire system. I want you to understand when troubleshooting, a lot of the times we take a unique test device to do a reading on it, and it's an amp test to see what's going on with the system. It's one of the most informative ways to understand what's going on with the system. So hopefully we'll get some of that covered in this short amount of time. Two-wire systems, like just about everybody has a two-wire system of one form or another. They've been around a very long time. They've gone through a lot of different changes. So they're becoming more and more popular. One of the first ones out there, from my knowledge, is built in 1966, was for agriculture. John Mansfield did it. And it was actually a four-wire system when it was first introduced. As time went on, they become more problematic, and it acted a lot like a Christmas tree light string. And I'm sure everyone knows what I mean by that. You get one bad light bulb, the whole string's dead. And then you know what to do. And that's how the very first two-wire system was. You had a bad decoder, and the entire system went down because of that one decoder. And then you had to go through and try and figure out which one it was. So they lost a little popularity at that point. In Europe, another company came up with another way of doing it, much like our new Christmas light strings, where one bulb dead, you know which bulb it is. And it became more popular at that point and started to see them become more popular as time went on. Here's a picture of one of the first ones. And I got to tell you, I hear this all the time from people. Oh, mechanicals were so easy. You had a dial, you had pins to push in, real simple. Okay, yeah, in the bottom left, you have your dial, you have your days. Excellent. You have your station programming in the middle where you put the pin in for your station runtime. That's all simple and straightforward. In fact, here in 1966 shows you a picture of a system that actually had water budget on it. That dial in the bottom middle that you see, 0.5, 0.75, or 1.0 for 100%, 1.25. So they actually had water budget back in the day. This thing was still working, and it came from a property out in New Jersey. But nonetheless, there's a lot going on. And when you get into all this stuff on the right-hand side, how you program the decoder, that's where it got really complicated. Nonetheless, they're an alternative to traditional systems. The key difference between them is instead of one controller operating this section here and another controller over there operating another section, you have one controller operating a bunch of little mini controllers, if you will, that are located throughout the entire property, all connected by a single two-wire path. It makes it real, I'm going to say, a lot easier to work with when you understand the concept. So they operate off of pulses. We got to thank our friends from Ma Bell. And the telephone back in the day was if any of you still remember the day that we actually had telephones connected to a wire in your house. Yes. And Ma Bell found a way to take that two-wire path for telephones and bring AC communication into that phone to make the bells ring when the call came in, and yet also had DC communication so we could hear the voice of that person on there. So it was a two-type system. It had AC for power and DC for communication. Now the DC isn't measured like traditional direct current. It's more of a communication pulse that's embedded on that wire path. Really cool how that all works. Now, communication is always two-way, meaning the clock knows the decoder got the information. The decoder responds back to the clock. Hey, we're good to go. We're going to operate it. The decoder, the little mini controller, as I mentioned, is out in the field. It can be hooked up to valves traditionally. It can be hooked up to moisture sensors to tell how moist the ground is. It can be hooked up to a flow sensor to let you know water is running or water is running when it's not supposed to. It can even be connected to weather stations. So there's a lot of different nuances to two-wire, not just valves. They can be a standalone controller operating up to maybe as much as 200 valves out in the field, or they can be interconnected through a central control system where you have several controllers operating several decoders, and this is where it gets really complicated. So try to keep it simple. You got standalone, you got central control. I like putting it in brand new, but there has been people that have successfully added onto an existing system or modified an existing conventional system. I caution you with that thought, in that because it's a two-wire path, if you're trying to find the two-wire path that's existing, make absolute certain that two-wire path is a good, clean two-wire path. Very important. And we'll get into that as we go through. They do have advantages, but yet they do have some disadvantages to them. One, a lot less wire. You got a 48 station system out there. You've got a minimum of 50 plus wires running throughout the area. A wire gets cut, you lose a one zone. But you have two-wire in this system, a two-wire line that feeds everything. So where the line gets cut, everything up to that point works, and after that doesn't work anymore. You can add on to it, but not indefinitely. And that becomes a very brand specific adding onto the system, how many you can add on. So the savings comes from much less wire, but now you're having little miniature controllers located out in the field. They're not cheap. Now you have a lot more wire connections, and we'll get into that in just a moment. So here's a 30,000-foot view of a system. No brand here, just a system. I need you to look closely at this picture, please. There are some things I need you to notice. First of all, look at the 2-wire path. Comes out of the controller with a black and a light blue color. Why are the 2 wires different in color? Because there's polarity to them. On an AC system, you got a hot wire, you got a common wire, and a common wire is unique because it goes to each and every single zone valve out there. On a 2-wire system, it's 2 wires, but they're polarized. Why? Because you got the AC on there, but you also have DC communication. So polarity is very, very important. Second of all, these little round canister looking devices are the decoder themselves. Inside that little canister is essentially a sprinkler timer. It gets information from the controller, says, oh, I'm supposed to turn on a valve. And I can turn on anywhere from 1, 2, 3, even 4 valves on a single decoder. Some now are looking at 6, maybe 8. Some decoders you can double the valves on. That's a brand specific issue. So double check what the brand you're using. Next, I want to call your attention, not to the polarity, to the decoder, but now notice the very end of the line. Your 2-wire path doesn't just arbitrarily end. It must conclude at a decoder being used for anything, a valve, a moisture sensor, a weather sensor. You just can't have the wire end. And there's some unique issues about that as we get further along. But I needed you to look and see from a 30,000-foot view what the 2-wire system is. Now, it can be added to a standard controller where you have a valve, a decoder, a valve, a decoder, and it just goes out throughout the property. Or you can even have a hybrid system where you can have a conventional system in addition to a decoder or 2-wire system. There's a lot of variety out there. When looking at a sports field complex, close to you folks here, on a conventional system, you'd have a clock for the soccer field, a clock for the polo field, a clock for the baseball field. You would end up having 2, 3, maybe 4 clocks out there and just a wad of wire feeding each and every one of the valves. That's pretty extensive. But if you were to consider a 2-wire option here, now you're looking at 1 clock and a 2-wire path that feeds the property. Now, this looks a lot more simple. The key piece to note here, say that 2-wire path that feeds the polo field up there, if that 2-wire path gets cut, baseball field, soccer field continue to irrigate. You just lose everything on the polo field, which makes it easier to troubleshoot in a sense. On a large parking lot or an office complex, you've got a huge wad of wires. But if you convert it to 2-wire, oh, it's so much more cleaner, easier. And I think for troubleshooting, it makes it easier as well. Because now you're not tracking all over the place looking for a different wad of wires. You just have a single 2-wire path that feeds all the islands. Howie project, same difference. A ton of wires. Well, 2-wire, much more cleaner, much more simpler. So it does provide you with a lot of opportunities. You can have long wire runs, brand specific. Some will let you go up to 15,000 feet, which is a tremendous length of wire out there. But it's only a single 2-wire path. Less labor because you're only dealing with the 2-wire path. But there's some other things we're going to have to cover. Now, I like this because in high vandal prone areas, everything is underground except for the 1 clock. And that can be mounted in a building, in a utility closet, or wherever it's safe. But everything else is buried. Everything else is in valve boxes. Everything else is out of sight, out of mind. So it makes it really, I would say, vandal resistant. Nothing's vandal proof because those vagrants can get in there and destroy things. What I've seen nowadays with the homelessness population growing and them wanting to charge their phones, charge their e-cigarette stuff, they're plugging things into wherever they can find a place to plug into. So vandals, yeah, they can get at it. You give them a chance, they'll get after it. Last but not least, the power consumption on a 2-wire system is less than a conventional system. Why? Because a little decoder is like a little miniature controller. And from that decoder to the valve, we're talking 12 feet, maybe 15 feet at max, maybe 6 inches for the most part. You don't need as much energy to turn the solenoid on as you would a conventional system. So power consumption is much less. Now, many brands have different ways.
Package, the mail would time through GPS.
I'll be darned.
Believe it or not, tracked it on their iPhone. They called the police, and we caught the mail.
Oh boy! All right, we have competition. So many manufacturers have a little tester. Many manufacturers have a program, a device that programs the decoders. So different things, different tools you have out there available to you. Hunter has one very nice tool that can be used for programming the decoder, testing the decoder, and even identifying the decoder. Key thing to note here, it works with Hunter decoders only. So the tool's good, great for Hunter, but if you're doing a different brands, a variety of different brands, you're probably better off with a different type test device. Here's showing how they connect it up. You've got your red wire, you got your blue wire, you plug them into the appropriate slots. You go to the face of the controller, checking for a decoder. Sure enough, look at that, lo and behold, we have one. It's a 2-station version, power factor and inrush. Guys, when you're dealing with 2-wire, the decoder itself is so close to the valve. One, you need to know what the pressure is of the valve, so you have your inrush factor set to handle the higher pressures. And then the power factor, if it's only 6 to 8 inches away from the decoder, you can use a much lower power factor to turn the valves on and off. So different things to consider. And once again, programming complete, you are good to go. Wire connections. I can't stress this enough. On 2-wire systems, 85% of all the problems that you're going to encounter out there are going to be related to a wire connection. And I will say each and every single solitary wire connection ever made will eventually have to be replaced. They don't last forever. And on 2-wire, specifically 2-wire, the wire connections are critical. One, because on many systems, that 2-wire path is live 24/7, 365 days a year, holidays included. That's a lot of energy through that 2-wire path consistently. Looking for flow, looking for moisture information. It's checking on the valves. There's a lot going on in that 2-wire path. And because of the communication piece, that's DC, which means that your potential for corrosion is much greater. So we have to be careful with the wire connection. Second, many of the 2-wire systems use 30, 40, up to 50 volts on that 2-wire path. It's a 24-volt style system, but the wire connections, you can't just use a standard, average, everyday, run-of-the-mill 2-wire standard wire connection. You have to use one that's designed specifically for 2-wire. We'll get into that a little bit more. So here's your standard 2-wire connection. Note the difference between the two. This is a clear or kind of a white colored connector. That's for your standard, average, everyday conventional irrigation system, 24 volt. This one here is designed for 2-wire because it's rated up to 600 volts AC on it. So the protectant inside the tubing is designed to handle the higher current. So when looking at it, you have your conventional, you have your 2-wire, or now they have this light blue colored connector, which is designed to be able to handle either the yellow or the red wire connector together simultaneously. We thank our friends at Page for providing with this color page, showing us what we got. But the key, when doing your proper connection, the wire nut has to be buried completely to the bottom of the connector. Here's a bottom photograph. I've seen so many of these. You got this waterproof connector. Fine, it's gel filled, great. But if you're not putting the wire insulation inside that connector, there's no waterproofing. There's no water protection. you've got exposed copper there. And oh, by the way, this guy pre-twisted the wire. And if you look closely here, you can see right there where the copper is cracked because he pre-twisted, and then the wire nut's job is to twist it even more. That's going to cause a crack, and that's where my problem of corrosion is going to begin right there. And oh, by the way, so he used electrical tape to continue the connection. Let me just say something. First of all, the adhesive on electrical tape is water soluble. Wait, what? Yes, it's water soluble, meaning you get moisture in there, the adhesive is going to start to break down and dissolve, as you see in the photograph, where the residue, some of it's there, some of it's missing. And oh, by the way, let's think for a second. Imagine your two fingers. Hold your two fingers up. If you're looking at your two fingers here, imagine that being two wires. And then go ahead and imaginarily wrap tape around your fingers. How waterproof is that? Oh, think about the gap between the fingers. Well, that's the gap that's between the wires, and your tape will never fill that gap. So electrical tape's never going to be an appropriate wire connection. It will allow moisture to get in, allow corrosion to occur, and corrosion is our evil, evil, evil arch enemy in the industry, with the dark cloak standing in the corner ready to prey on something. Tape is nice, and a bare minimum will help, but for waterproof wire connection, not effective at all. So when doing a two-wire system, we need to understand some nuances about it. When comparing it to a conventional system, in this example, we have 40 stations. In this system, for example, we've got wire feeding all these 40 zones. When looking at it, you've got a wire for each of the zone considered the hot wire. Then you have a common wire that's the return path to the controller. And in this scenario, I got to ask you, how many wire splices do you have to make the station number 40 operate? Good question. Going to take some thinking. I'm going to say at a bare minimum 41, because you got maybe one for each all the common wires. I don't know. That would be a lot of wires in a single connector, but it could be up to 80 connections. When you're looking at a two-wire system, the same scenario, I'm trying to get to station 40. Now you got to look at the different wire connection along that path, that two-wire path. Now, getting to that 40th zone, how many connections do we need at this point? The bare minimum. You need two connections for each of the decoders. You need two connections for the valve. So we're looking at a minimum of 82 in this scenario. A lot more connections and a lot more opportunity for trouble. So about the cable, you have either at the top, just a standard 14 gauge twisted pair wire, or you could have parallel wire. And you have wire that's specifically made for different brands out in the market. I got to tell you, 14 gauge wire is 14 gauge wire. It's used for power, also used for communication. So if you're going to be using it for communication, bear in mind the harmonics of that wire. Yeah,
Oh, great. Yes. Only that this jump. Okay, we'll stick it to 630D, yes. The 630D goes to 630D. Yep. We'll do it right now. Okay. Thank you.
Got it. So we have a wire path, and you got communication on the wire path. Imagine driving your car on a boulevard. What happens to your radio when you go underneath the high power lines? You get static, or it loses your satellite signal. Well, you've got that same kind of noise, if you will, going down the two-wire path. So if it's a twisted pair, that harmonic dispensation is retained closer to the wire itself. When they're laying flat parallel wire, the dispensation or the emission of that static noise is a little bit broader. So maybe a twisted pair would be a slight bit better, but negligible at that. So whatever wire you use, it works fine either way. Twisted pair or parallel, either way works. If you've got a project that's specified to have Toro wire, then use the Toro wire. For Maxi wire or Rimert or Remaster wire, yeah, those brands are specific for the brand. And if that's what the specification calls for, by all means use it. Here's an example of twisted pair. as you see it coming in from the bottom, it's twisted pair coming in, and note the color of the wire connection here. That's for 2-wire, the 2-wire path here. Now, once you come out of the 2-wire, you can use standard run-of-the-mill waterproof wire connections from the decoder to the valve itself. This brings up a very, very, very important aspect. I gotta say, if you're using a Toro brand 2-wire, you absolutely positively must use Toro brand decoders. If you're using a Hunter brand system, you've got to use the Hunter brand decoders. They're brand specific. What valve you use can be whatever brand valve you would like to use. I would prefer Toro, but it doesn't have to be a Toro valve with a Toro system. It can be a Rainbow valve or a Hunter valve. Either way, the decoders must be brand specific to the controller, but the valves can be different ones out there. In some systems, you can loop it. I don't recommend it, but you can loop it and get a little further distance out of your 2-wire path because of the power shared. But either way, you've got your system, you've got your decoders, and then you have your surge pill, if we call it a lightning arrestor device, and a ground rod. Where you put the ground rods, very specific to brand, but in general, they're approximately 600 feet apart. And don't put the ground rod in the same valve box as the decoder. You want to move that ground rod away from the 2-wire path, and we'll get into grounding here in just a few moments. But that just gives you an example where the decoders and where to put the lightning arrestor or the ground rod. All right, whether it's a loop or you go out and spread off in different directions, always, always, always remember to put the wire connection inside of a valve box. So important that you do so you, one, can find it to replace it if need be down the road. So very important. How you do the grounding of them is also a brand specific scenario. Here they show the surge arrestor. Here this guy recommends a ground plate with that fiber or fill, as they call it, a moisture enhancement material around the ground plate. Either way, and this guy has 500-foot maximum distance. If you're living in Florida, yes, I think grounding is critical. If you're living in the Sahara Desert, maybe not as critical for grounding. It's all about what your lightning potential is. Up in the mountain area, you have a higher lightning potential than you do down towards sea level. But nonetheless, lightning can still occur. So we have to be aware of it and protect for it. Here's now, that's really not the best picture. But again, another brand showing you their specific detail on how to hook up the system with the decoder, the valve, and lightning or ground connection. All right, here's another example here. This guy obviously has a little bit more desire for wiring. They've got a ground wire traveling with the 2-wire path going to a ground plate. So either way, look at the brand that you use and their specifics to their details. All right, grounding is important. It's a critical piece. Now, I don't have an idea why this guy, one, is smiling, first of all. Two, the guy on the makeshift ladder, not an appropriate ASA design setup. This isn't safe. One missing that hammer and that guy's gone. Oh, by the way, case in note, National Electric Code requirements state that ground rod, if it's 10 foot, like it looks like here in the picture, that needs to be 10 feet away from the pole we're protecting. This ground rod here, that ground rod there, this is like 4 feet away. That's maybe 2 feet away, body length. These aren't being installed in the proper location, nor by the proper people. Moving on. So it's the sphere of influence. If you get a surge, a lightning surge, a power surge of some sort, it's getting swallowed up by the 2-wire path. It's making its way towards the controller. It's making its way towards the decoder. When it comes to the decoder, it's supposed to channel through the surge device out to the ground rod and dissipate into the soil, making this sphere of influence pretty large. Typically, the length of the rod is your sphere of influence. So if it's an 8-foot rod, you've got 8 feet from this end to the rod and 8 feet from the outer edge into the rod, which is my sphere of influence. I don't want anything in that area. I want to be able to dissipate the surge away from any wire path. If you put 2 ground rods in the ground for better protection, be aware of the distance between them. You put them too close together, you're not going to have an appropriate protection from that grounding setup. Ground sphere or ground plane, your sphere of influence is predominantly on the leading edge or away from it, not side by side. So it's just an example of, again, the sphere of influence on that one. Because surge can happen. Now, I got to say, we're not making the space shuttle anymore. We're working on different things from our friends at SpaceX and whomever. But you think these people would have a pretty significant and pretty decent surge protection for lightning here. And in this photograph, there's my lightning rod up there. When Mother Nature wants it, all I can say is Mother Nature's going to get it, like the space shuttle in this picture. This is what should have happened and what happened at another time. And I got a question for you guys. Think about it. How is it these people can take a picture of a lightning bolt landing like that? Just happen to have a camera just aiming at it, ready to go? I don't know. So grounding is important. Making certain your dissipation is away from anything that'll be picked up so that the sphere of influence isn't in contact with that 2-wire path. That's the walk away. Whether you use a ground rod, a ground plate, that's just a ground plate coiled up. Over here on the left, that is a surge device that you put at the controller. Probably one of the higher end quality surge protectors. You've got a little screen here, which gives you a green light when it's working. And if the green light's not on, it's not necessarily properly grounded and probably not working. So good devices to have. Because this, honestly, can happen. We don't want this to happen because that's a mess. That's a surge that wiped out a whole bunch of stuff. So again, lightning can happen. And to finish up with grounding, your sphere of influence, whether you use a ground rod, the ground plate, again, put them perpendicular from each other and away from the clock, as well as away from the decoder. And again, connection should be done in a valve box. One, so you know where the ground rod is, and two, so you can get to the connector if you need to. Because if we have everything too close together, due to the sphere of influence, as a famous author of science fiction once wrote, it's like a snake that eats its own tail, forever without end. So we don't want the wire to pick that surge up and go back into, I don't know how they got that snake to do that. I don't know how that's going to end, but I don't think it's going to end well. I'm just saying. So now there is a device. Page Electronic makes it. It is clever. I've seen it used many times. And when I go out to troubleshoot, it makes my job really easy. It's a little device you install on the 2-wire path that connects to the decoder and an intersection with 2-wire path so that it can be isolating different directions of the 2-wire path. So when you're troubleshooting, I can shut that leg off and be able to troubleshoot the rest. And I'll show you some pictures of such device later on here, depending upon our time. So make certain you have the brand specific decoder with the brand specific controller. You hook it up to the programming port as you see here and as you saw earlier in the screens. You connect it up, all right? Set up the 2-wire decoder, program the decoder. All right, I'm going to address it right now. I'm going to call it station number 1. I click to address it. It says, okay, I communicated. Guys, the decoders have 2-way communication. So now it says it's okay. Address is now considered station 1. All right. Let's get into the fun part, probably what a lot of you folks are here to listen for, not just the design aspects, not just about the unique pieces of 2-wire, but let's talk about troubleshooting, because this is going to be a big part of our lives moving forward. So, as mentioned previously, different brands have different brand test devices, but those brands test devices are brand specific. You must use the test device for Hunter devices, Toro for Toro devices, Ringmaster for Ringmaster devices, and so on and so forth. If you want one test device that works with every manufactured 2-wire system, that would be a what we call a clamp meter. Now it's a specific one. On the meter itself, if you can see real closely in this photograph, it says down here underneath the display, leakage current tester. This clamp meter is specifically designed for 2-wire low current readings. Your average clamp meter will not work on 2-wire. They are not able to read, fine tune, the current that we typically use on 2-wire. You must have this device here is not an inexpensive device. It can range from $250 to $400, depending upon what one you get. Underhill sells one. Armada sells one. Fluke makes one. Many different brands. X-Tech out there. There's a lot of different brands out there. It just has to be a leakage current device. That's the walk away. That's what you must know. It must be a leakage current device. Be able to read small milliamps going out into the system. So with that in mind, this one here from Meter Man, I think this one got bought or taken over by Xcore. But whomever your supplier is, they sell them. It's just got to be specific for 2-wire, meaning it's got to say like this photograph shows leakage clamp meter, leakage current tester. That's what we're looking for. All right. If you have the brand one that can go in and test their decoder, of course that will work. But again, it only works specifically on that brand. This one here happens to be the Toro or a Rainmaster device, or they're different. But this one here tells you what station it is. It looks like to be station number 2. And then you can go and program to the next one or test it to see, is it a failure or does it not read the decoder at all? So the programming device, this field device, can be used to program them and be used to test them. So, key takeaway on AC decoders, doesn't matter the brand, their wiring voltage typically can range between 33 to 50 volts on there. 1 or 2 station decoder, the current draw on that one decoder is 0.5 milliamps. That is incredibly small current draw. That's why you need that specific test device to be able to measure the milliamp draw on that decoder. There's 4 stations, 6 stations. Rainbird makes a 6 station and an 8 station now. They draw about 1 milliamp. The key thing is to know what you're using and to know what you're reading for. Now, I have done a lot of troubleshooting out in the field. And I got to say, what the individual decoder current draw is important to know. And I know many brands tell you to go, okay, if you got 100 decoders and 1 milliamp per decoder, then I should have 100 milliamps out there. There's going to be current draw through the wire length. There's going to be current draw due to the wire connections. It gets higgledy-piggledy if you're going to follow that line of reasoning. I find when troubleshooting, get a reading at the clock. What is that reading? Is it considerably higher than what you expect? Or is it within range? And that's your starting point. DC decoders, there's a few of them out there. If you look at this, a DC decoder has a current draw of 0.6 milliamps. What was the AC? 0.5 milliamps. They're negligibly different. Line voltage 40 volts. Well, this is 33 to 50. I think they're pretty much in line with each other. Whether it's DC or AC, your current draw is relatively the same. And when you're doing troubleshooting on your 2-wire path, the current draw is reading the current draw of the decoder, whether it's turning on an AC valve or turning on a DC valve. The current draw on the 2-wire path is similar. When you turn on an AC system, the key thing to know is when you turn an AC valve on, that current draw is constant while the valve is running. On a DC system, it is just a pulse to turn on the zone and then a pulse to turn that zone off. So your current draw is a little bit less than a standard AC, but when troubleshooting, the process is the same. So what are we doing? You're taking your 2-wire path, separating it so you can read the current draw on one individual wire at a time. You will get the current reading this way. You can't put the 2 in there together because then you won't read the flow properly. You got amperage draw going to the right and amperage draw returning back to the clock. You're going to read a 0 if grabbing the 2 wires together. So what is this? This is the current draw of a single decoder. This happens to be 0.6. Look at the picture, milliamp. What kind of meter is this? A leakage current testing device. This one happens to be X-Tech. what the X-Tech purchased the Meter Man brand years ago, but that's trivia that we don't need to fuss or worry about. But 0.6 milliamps, that is a good decoder. That is not my problem. Here is a 5.96 milliamp on a single decoder. That is a bad decoder, and that is drawing too much amperage. So here's where we found the bad decoder. Now, in looking for the bad decoder, you're doing a lot of deep knee bends because you're going to go from valve box to valve box to valve box to valve box, and you're going to grab the wires inside that valve box and clamp around individual wires. Always check each wire in the valve box and look to see, what did I start with at the clock? Each valve box, you will see a smaller current draw as you go through, looking for where the problem lies. This one happens to be 5.96 on a single decoder. That's huge. That is bad. This one here, 1.82 milliamps, that's also a bad decoder because it's supposed to be 0.5 or 0.6. So that's like triple. So that's how you find the bad decoder. And it's a matter of just walking around and seeing. So in this diagram, you follow what this is saying here. You start at the clock, you separate the loop, as we did in this photo here, and you work your way through and you're bending over into each valve box. This valve box here, as I've got my arrow pointing at, is what I call an intersection. I got a 2-wire path coming in, 2-wire path going off, and a 2-wire path going in another direction. So it's like a 3-way intersection. You will have a minimum of 6 wires in that valve box, meaning you will have 6 wire connections in that valve box. This is a great place to put the isolating device in there. So now it can go and have a switch that turns that power on, a switch that turns that power on. So you can isolate to see where the problem truly lies. Now, if you're using your clamp meter, I see 0.012 going down here. That's good. 0.250, that's high. I know my problem is off to my right. And just follow the path through and work your way through the system. That's all you're doing. So here I'm starting at the clock and I'm reading 225.7 milliamps. That is high. That's incredibly high. Not enough to blow the fuse, but it's high. And I got to stop right here because this is a perfectly good spot to do this. If you're blowing the fuse on the clock, we need to figure out, is it because you have a bad board or do you have a bad 2-wire path? Remove the 2-wire path from the system, replace the fuse and see if the fuse blows again. If the fuse blows again, then you got a bad 2-wire board in the controller. If the fuse doesn't blow, next step, I do this. I ohm check the 2-wire path at this point. It's not connected to the clock, it's been removed. What's the resistance on that wire? On a good 2-wire system, your resistance should be open. Very important. The resistance on a standard, typical 2-wire path, the resistance is open. If you're reading a short circuit, 10 ohms or less, you have a short in that system and do not connect it to the clock because you're going to blow the fuse again. In which case, troubleshooting that, which is quite common, becomes a process of going from one valve box to another and ohm checking each one, meaning you're going to be cutting the wire connections and doing an ohm check on them. And just find where the shorted decoder is or the length of path between one valve box and another where the short circuit is. Complicated, time consuming, and a lot of bending over. Otherwise, if it's a high current draw like you see in the photograph here, 225.7 milliamps, this one's not blowing the fuse, but it's a high current draw, and I now have to follow the 2-wire path and go out in the field. From the clock to the first valve, oh my gosh, that's 813. That is huge. And in this situation, what this one turned out to be when I was doing it, it turned out to be a surge pill. If you look at the picture here, right here at the bottom of the screen, that is a surge pill. And if that thing got hit with lightning or got hit with a surge, it will short to earth ground, and that's causing that high current draw. But it's a matter of just bending over into the valve box, grabbing the wire path, and separating each path so you can clamp around, as you see in the photograph, one wire at a time. And you're just going to go through that 2-wire path from valve box to valve box to valve box, and just keep reading. I'm back to 223 again. As you work your way down the line, you'll find the decoder that has the high current draw, as I did in this photo here. So that's what we're doing. You're just walking through the system, moving your way down the 2-wire path where you can. If you have a looped system in this example here, remove the loop from the clock. So I'm only following one 2-wire path itself. Granted, you may have not been the installer, in which case you don't know if it's a loop wire path or not. In which case, what do you have? I remove the 2-wire paths and leave only one connected. Check it. Is my current draw normal now? Check the other 2-wire path. Is that one normal? And check each one of them and find the one that's got the high current draw and then follow it out into the field. First things first. I should have started with this. I apologize I didn't. When troubleshooting, trust the diagnostics of the controller itself. It can be very informative. Turn the clock diagnostics on and ask it to identify how many decoders does it read? What are my error messages? Is it telling me I can only read 50 out of the 65? Is it only reading 12 of the 48? You need to find out. A lot of the clock self-diagnostics, very beneficial, and they will tell you whether you have a high current draw and it's shutting it down because it doesn't want to damage the clock, or it'll tell you, I can't talk to zones 1, 7, 9, 13, 24, and 36. It will tell you if it's not communicating to it, it's a good likelihood the wire connection has gone bad. Now we have wire connections a little bit later in the presentation here, but the diagnostics of the clock, very beneficial. Start with it. You're at the clock, start there and do a diagnostics and read what it says. And at least that can give you an idea of what you're up against when you're going out to troubleshoot. Very important. Next, use your clamp meter and isolate the 2 wires far enough apart to get your clamp meter in there and do a reading. And take the amp read and just move from each wire path. And always check every wire. You got 2 wires, don't just check one and call it good. You got 2 wires, check both wires individually. You got 6 in that box, you're going to be checking 6 wires individually, one at a time. You should be able to determine power in, power out, and at each valve box with a decoder in it, your reading should lower by that of the current draw of the individual decoder. You're in the valve box, check the decoder while you're there. Do a reading. Make note of what you see and work your way down the path. I know time is money. And with 2-wire systems, there's a lot of investment in that system that was put in. But when it comes to troubleshooting, don't skip a step. Always hit every valve box. One, check the connections for loose wires. Check the connection that the connection is not corroded and not shorting out. Using your clamp meter. Here's another type of clamp meter. Again, they must be a leakage testing device, okay? A leakage current tester. Some decoders, really cool. Some decoders have lights on them. That's nice. You see the picture on the right shows a picture of the 2-wire path lit, meaning it's communicating. The picture on the left shows you what zone line or zone wire is connected or turned on. Cool. However, I will tell you from personal experience, when you're out, full broad daylight sun blaring down upon you, those LEDs are a little bit difficult to see. Don't trust them. Yeah, they're there. They're nice to see. Trust your meter. Don't always trust the LEDs because they're hard to see. And in fact, many times in broad daylight, LEDs look like they're lit even though they may not be. So again, nice to have, cool to look at in a lab. In some cases, a valve box that's dark enough, you can see the LED, great bit of diagnostics, but your meter is going to be your best tool to use. This one here shows you the programmer. You can plug it in and test the decoder. Guys, the main benefit to a clamp meter device is you're clamping it around the wire connections. You're not removing the wire connection. To use one of these testing devices, you are removing the decoder, meaning you're removing the 2-wire connection, meaning you're going to have to replace the 2-wire connection. That's a lot of work. And if you have a decoder that's shorted out and the current draw is so much that it's popping the fuse, well, yeah, you're going to have to redo the wire connections anyways. And in that scenario, if you're going after the shorted decoder. I always go out to the end and work halfway towards the clock, then halfway again doing your current draw, looking at the current draw, or doing your ohm check. Take steps to see where the problem lies and follow the path. So when it comes to wire connections, as I said before, wire connections, it's important to know what kind of wire connection you're using. One, they got to be waterproof. Two, are they on the 2-wire path or in the solenoid wire? Know what connection you're using and how to do it. Very difficult. So in your wire protection, make certain you're using as much waterproof connection as you can. Critical. They must be UL or another underwriter laboratory or another agency for testing. And there must also be UF, which stands for underground feeder. UF for underground direct buried connection. Electrical tape will not work. They must be waterproof. They will state on their package if they're waterproof or not. No, I've never seen bubble gum on a wire nut. I have seen PVC glue in a wire nut, which no, that's not waterproof either. So guys, there's a lot of different variances that I've seen out there that I would say some are good, some are okay, and some are not good. And it took me years to figure this out. We get paid to sniff glue on irrigation installation. And because of that, our creativity can be very creative. But don't be creative on the wire connection, please. It's so darn important. Use a good waterproof wire connection because this can happen. Look at this here. The wire connection is corroded so bad, it's no longer a connection. Look at this one here on the right side of the screen, just to the right of the valve. That green stuff is what used to be the copper wire. It just corroded through. This one happened to be down in Lake Elsinore, and working with the contractor, I said, why is this happening? He says, well, I used my pocket knife. I cut the insulation so I could do a voltage reading. You what? He said, yeah, I folded it, took a knife and cut the insulation open. I said, well, herein lies why you've got this problem. Remember, a 2-wire system is running 24 volts to 30 volts to 50 volts down that 2-wire path, 24 hours a day, 365 days a year, even on holidays. With that potential, your corrosion opportunity is much greater. So be careful. Don't cut the insulation. That's compromising your system. You're going to cut it, resplice it. Because connections are critical. Yeah, I love this one. There's my common wire. There's my hot wire tied together in the connector. That's a direct short. That's the common wire that should have been in there. That's not good. This one here, beautiful. This guy soldered his wire connections. Oh, how cool is that? He soldered them, but there's no waterproof protection on it. That's not good. This one here, oh, we saw this picture already. Look at this one. All the protectant came out of it. It's no longer got protectant inside it, so that's no longer a waterproof connection. Watch out. Be careful with what you have out there. Again, wire nut needs to be all the way down deep inside that wire connector to the bottom. And I do know in many cases that is difficult to do. This is why, if you need to, use a sprinkler flag and push the connection all the way down to the bottom, pull the flag back out now, and push the protectant back in the hole so you have a good waterproof connection. Here's another example. There's your waterproof connector. There's the waterproofing, but the copper is not inside that wire connector. This isn't waterproof. Even though we got the tape on it, it's still not waterproof. So other options. Looking here, when you're cutting the outer insulation on the 2-wire path, be careful not to cut into the wire inside it. Proper connector or proper wire cutter is critical. They sell a device that's called a jacket stripper. A jacketed stripper has a vertical blade that cuts parallel the wire, not horizontal the wire, so that it cuts just lightly into it, and you can peel it open to get to the wires. Another way is to use something like a linoleum knife and just put a very, very slight cut on this side and on the back side and fold it 2 times and it cracks it through and slide the sleeve off. Wire, careful with the wire. Use the proper connector. Look at this one. You can see the green corrosion on the surface of the wire. You can see the green corrosion inside the wire connection, and you can see it right there. The proper connector. This is a good connector for the valve wiring to the solenoid, but not on the 2-wire path. It's not designed for the higher current draw. Push the stuff back into the tube so you have a proper waterproof connection. Be careful with what you use. Make certain the connections pushed all the way down. Don't put too many wires in there and it just won't fit. There is a limit to how much you can shove into a single connection. Watch for the stuff coming back out of the connector. Look for it. Be careful, aware of. And again, don't pre-twist it because you can crack the darn thing over here. Look at this one on the left side. Boy, it's had a lot of wires pre-twisted, and that one broke right here. Finding these things can be a challenge. And oh, by the way, don't be that guy. He just looked at, I looked at him, I go, wait, what is that? He says, I just pour PVC glue inside the Rubbermaid tub and call it good. That's not waterproof. That's not good at all. Don't be that guy. Be careful what you're using. Here, if your corrosion's so bad, the wire just comes right out of the connector. As with this one here, when I grabbed the wire, it came right out of the connector. It's so corroded, the copper is no longer there. Watch for that. Be aware of that. Look at that corrosion there. And this was on a 2-wire system. That much corrosion occurred in, I'm going to say about 3 to 6 months. It doesn't take long for that much corrosion to occur. So by all means, waterproof wire connection is the key to setting the system up. Look at this. There's so much corrosion. It's turning black in it. And if you've got the wire pre-twisted so much where your pliers leave marks on the copper, you're going to break a copper connector or the copper wire inside there. Don't pre-twist it. If you have to twist it to get it together, don't twist it tightly because the wire nut will continue to twist it when you put the wire nut on it. So we have to be careful. Be very careful. Look at this here. There's my wire nut. The wire's corrosion right there is so bad. The wire connection here, it just came right out. It just broke right off. That is not good in any way, safe, or it's just not good. But note, this one, he got the wire all the way to the bottom of the tube. So very important. I don't even know what to say about this one. What a smorgasbord or a buffet line of different connections. Be careful with what you're working with out there. This one here, I just couldn't believe this. This was a 6-inch round valve box that was on top of 2 other valve boxes. That thing went into the ground about 3 feet. And what did I do? I grabbed it and pulled out 5 different decoders in that valve box. And look at the picture. Not a single one of them was waterproof connection. This is a mess. That's a total mess. This one here, the copper wire got compromised. The corrosion occurred so bad that the copper wire inside that wire is missing. This took me, I'm going to say close to a week to find it. A nick in the wire, that'll ruin the wire. So the wire conductor is so important. The condition of it is clean. When I said at the beginning of the presentation, please, if you're going to modify a system, make absolute certain your wire integrity is good. That's critical. This can happen. Be aware of it. Be careful. Can't say it enough. And I just have literally thousands of photographs of situations like this where the copper is gone. It just came apart. The proper connector is paramount to 2-wire systems. This one here, as you can see the little teeth, a rodent got to this. Started to chew it. You can see the corrosion there. You can see the wires missing right here. And you can see where the 2 wires were arcing against each other, causing the short circuit. So please be careful. I tell people, use conduit if at all possible, so that you can find where the 2-wire path goes, so that you can protect it from becoming bait to the subterranean mammals of the property, to protect the wire from getting eaten. Can't stress this enough. And make certain you have the proper connector with the proper goo designed for what wire path you're working with. Be careful. And wire connectors, they be what? Maybe $1.50 each, maybe $2. But if they protect and provide you with years and years and years of protection, they're a good connector. The cheap connectors, they won't last. So I can't stress that enough to you. So I think I've pretty much made my hour presentation last about an hour. I need to just state, this was a very tertiary look at the 2-wire systems. This just gave you a general idea of what makes them different than conventional systems. The takeaway from this, wire connections are critical. Proper connector is critical. Using your clamp meter to test the system is critical. And in some cases, sure enough, an ohm check will find the problem also. Hopefully, I don't expect you to be experts at this time. Maybe this was review for some of you. Maybe this was brand new for some of you. Don't let this discourage you. Keep in mind, I'm here to be a partner. I want to help you build your confidence. Practice makes perfect. Me with our company, with Chris Steele, who helped provide me the opportunity to help you guys out here. We want to be your partners. What brand you use is your decision. What support you get with that brand comes from that brand. And hopefully you do get the support you need, because no system is perfect. Something's going to go bad somewhere along the line. And hopefully you've got somebody that you can lean on to help you through it. And last but not least, I do hope I gave you some new tools, some new ideas about 2-wire. Again, this is a 4-hour course that I normally teach, condensed into 1 hour. There is a lot of data that I didn't provide. I just didn't have the time for. So hopefully this gave you some interest, gave you some confidence. Look to doing it down the road. So my last question to you is, how do you feel at this point? The guy on the left or the guy on the right? That's typically me on the right. You might be the guy in the middle that says, or, I don't know. But thank you. Thank you so much for your time. Thank you for listening. And I'm going to turn it back over to you.
Okay, thanks, Craig. Does anybody have any questions that are present today for Craig?
Silence.
Craig, do you have your contact information maybe that you could
I'll
share with
email
the
it to
group?
you
Or
right after we're done. All right.
okay, great.
You can
great.
provide it to whomever
Okay.
asks. All right.
Yeah.
Unless I can give it. You can give me my cell number.
Yep.
You want to take it down? It's
this-
951-236.
Yep.
2431. That's my cell. 951-236-2431. Anyone needs to contact me, they are welcome to call me.
Okay. And then we'll also put that on our NorCal website, you guys. Okay.
Well, I thank
So if there's no more questions, we really appreciate, Craig, you joining us today. It was very informative. I know that there's a lot to cover. I'm sure even a 4-hour presentation would be, even after the 4-hour presentation, there's probably still more to cover.
Oh, absolutely. You can go on for hours, actually. Just amazing.
Yeah, yeah. So really, I really appreciate it. Thank you. This presentation is going to be, it's a tape presentation that will be on our YouTube site. So keep in that information on that will be on our website for NorCal STMA. And also we have another event lined up in either April or May, but pay attention to the website. Again, Craig, thank you very, very much. And thank you all for joining us today.
My pleasure.
Have a good rest of your day, Craig, and everyone else. Thanks again, guys.
All right, take care. Bye
Thank
now.
you guys, appreciate it.
You too.